Welcome to this course lecture series Manufacturing Technology second unit lecture 13 cutting tools geometry and the metal cutting operation. In this chapter I explain for the very detail and point to point. Okay, agenda for today present in this video the machining times and power estimation, and the second is the cutting speed in turning is the surface speed of the workpiece. Okay, the this is the topic is the very important in the chapters. Okay, that machining times and power estimation also explain for the sum of point in the last lectures. Okay, and in this the main important things in this video of the topic cutting tools speed. Okay, in by use in this operation for turning is the surface speed of the workpiece. Okay, to start for this the speed, find out the speed of the tools and the machining speed for the machine surface and diameter of the workpiece and normal. Suppose that this is the standard formula of the speed. The turning of suppose the turning operation is required for the sum of standard parameters in the cutting speed is turning is the surface speed of the workpiece. Okay, suppose that the this is the workpiece. Okay, this is the workpiece, and the the this is the holding of the job. Okay, this is the hold for the job in the chuck. Okay, in the chuck of the machines, and this workpiece is also rotate for the chuck is given for the speed in revolution in rpm. Okay, and this suppose n is the value of the n is the value of number of rpms. Okay, कितने नंबर से पर मिनट में घूम रही है वर्क पीस, एंड द वी इज द स्पीड ऑफ द टूल्स. ओके, कटिंग स्पीड ऑफ द टूल्स. ओके, सरफेस इन मीटर पर मिनट कितने स्पीड से वर्क ऑपरेशन स्टार्ट, एंड डी इज़ द डायमीटर ऑफ द वर्क पीस. डी, दिस इज़ द डी. D is the diameter of the workpiece. N is the number of rotations. Okay, number of rotations as number of the workpiece. Okay, in RPM, कितने RPM से ये वर्कपीस रोटेट कर रही है. इन द फाइंड आउट द वैल्यू ऑफ द given for the two or three values, and find out the easy one values in this is using on this formula. Okay, and the this is the standard formula. V बराबर, V is the velocity, V is the cutting speed. V बराबर pi d n upon 1000. Okay, this is the standard formula of the find out the value of speed and the diameter of the by given for the value of n and v, and then find out the value of diameter of the workpiece. Okay, easily. And the second is the given for the value of diameter of the workpiece and velocity speed of the speed of the cutting speed is given. Then the will find out the value of n, कितने स्पीड से हमारी वर्क पीस रोटेट कर रही है. फाइंड आउट इजीली एंड वैल्यू इज फाइंड आउट द. ओके, एंड सेकेंड इज द आल्सो फॉर द गिवन फॉर द टू वैल्यूज एंड डी और एन, and third find out the value of v is very easily in the y is the help of this formula. Okay, and the v is the cutting speed. V is the cutting speed of the surface. Okay, meter per minute, and d is the diameter of the workpiece is mm. Okay, and this and n is the rotational speed of the workpiece in rpm. Suppose that this is the value is meter and one value is mm. Okay, and second is the rpm. All the value is different. Okay, different parameters. The and the diameter d is the use for the either for an initially diameters, okay, and the initial diameter and the blank of the final diameters capital D of the small d minus capital D, okay. Find the thickness of the workpiece, okay, and the workpiece is after given for the depth of cut, okay. For the however, the practically not match charge when charge find the value of obtained by using the the value of the equations, okay. The cutting speed in the turning operation. This is the turning operation in also find out the value of the v and d, okay, and some of parameters, the elastics, the average of the two diameters, and the better from the equation is the v n equal to find out the value of rotation, okay. N is the value of n equal 1000 and v by pi d, okay. This is the also the rpm obtained for the previous equation may not be exact value of the speed available on the lathe machines, okay. This is the for one, since the lathe machines would we only have the limited range of RPM. The I also discussed for the second unit in the lecture for last lecture for the 21, okay, 21 22 lectures, okay. I also given for the knowledge of the machines required for the diameter increase and the velocity and rotational speed of the also decrease, and the other is the diameter also decrease and the speed also increase. The more the previous equation for the exact, since the lathe machines are also limited range, okay, there is the necessary to the adjust for value of obtain to the available on the workpiece for range of the consideration of the work tools material compositions. All the need of the other parameters is very important for find out the value of n and v and a, okay. The cutting speed in the turning operation. Suppose that demonstrated later for using the examples, the time, the machining time t, and for the single pass is the given for the to find out the value of t, and t is the also l is the original length, and L naught is the local length of the workpiece, and second is F or N. F is the provided for the feed rate of the tools, and mm per minute, okay. And the N is the number of rotation of the workpiece, okay. L length of the jobs, and L naught is the travel of the tools, okay. The L naught is the tools the distance, tools is the also travel for the distance, okay. L naught the beyond for the length of the job helped in the setting of tools in mm. F is the feed rate, per revolution, okay. Feed rate also fixed for the tools of the direction, and the overall the travels to the provided for depend upon the and the operation choose for the usual value could be 2 to 3 on either side, okay. This is the equations also provide for the this is formula is the very important formula. Find the value of the travels of the tools of the workpiece, and L is the original length of the workpiece, and the F is the feed rate of the find the thickness of the workpiece, okay. T is the time find the value of times, okay. Cutting speed in the turning operation. Suppose that the number of passes required to machines a component depend upon the leftover stock, okay, and top allowance. The allowances is also provide for need of the jobs. where DA is where the also for value of other parameters in the this is the PR is the value of PR is the value of PR is the A minus AF upon DR, where A is the total machining allowances. Okay, A is the total machining allowances, and the second AF is the finished machining allowances. Okay, AF is the finish. Okay, AS is the finish machining allowances, and A is the total machining allowances, and DR is the depth of cut in the r- roughing surface. Okay, in the roughing, the depth of cut. DR is the depth of cut for the roughing in mm. The value of calculated to the above for equation is the round of the is the next entire for similarly the finishing operations. Finishing process for the fs is given by the fs is the value of the f, the finishing process. Okay, finishing process is fs is the this is also second is the standard formula फिनिशिंग प्रोसेस और के कितने प्रोसेस में वर्कपीस फिनिश हो जाएगी. ओके, D is the DF is the diameter of the finish, depth of cut in the finish. DF. Okay, DF is the DF is the depth of cut in the finishing. Okay, in mm. Okay, depth mm value is given for the mm, and AF is the also for finishing machine allowances. Okay, PF is the finishing process. Okay, all the value is the all the value is the given, and one value, one or two values is given in this problems, and third value is find out. Okay, and third two values given for the and one value find out, and one value is given for the and two values find out the related to the need for the comparisons for problems. Okay, numerical analysis, and some of the find solve is these problems and related to the explain for the last formulas. Okay, estimate the actual machining time required for the component, and by the component is made for the carbon stage. Okay, so the figure, this is the job. Okay, this is the job. Okay, and this is the center of the job, and this is the 5 by 20, this is the depth of the okay 42. Okay, machine example for the spindle speed also variation is the 71 110. Okay, 110 and 176, 280 and 440. Okay, 700 and 1100 and 1700 and 2800. Okay, the variation of the spindle speed. Okay, variation of the spindle speed is the roughing speed of the 30 mm, roughing speed RF. Okay, roughing speed is the, and the finishing speed is the fs. Vf is the finishing speed. Speed is the given for the v. Okay, 60 meter per minute, and speed of the roughing is the 0.24 mm per revolution. Why the and the finishing is the 0.1 0.10 mm per revolution. The maximum depth of cut of the roughing is the 2 mm, and finishing allowances may be taken as the 0.75 mm, and blank to be used for the machining is the machining for the 50 mm diameters. Okay, and the stock of the removed for the operation remove for the 50 to 40. Okay, this is the value of the 50 minus 42 given for the value on this okay, mm, find the value of the 50. This is the machining. Okay, this is the machining diameter, capital D minus depth of cut. Okay, this value, and upon 2 is the finishing allowances of the 0.7 mm. Find out and the stock of remove for the 4 mm, and finishing allowances is 0.0. This is the given value in this problems. Okay, and roughing, find out the value of roughing. And the roughing stock is available for is 4 minus 0.33 is the roughing of the stock available for the 3.25 mm. Since the maximum depth of cut to the taken for 2 mm, there is the two roughing forces. Given cutting speed is v बराबर 13 meter per minute, and average diameter, find out the average diameter of the 50 plus 42 upon 2 equal to 46 mm. Okay, average diameter, find out the average diameter, and the spindle speed, find the value of n, and support we were our formula pi d dn upon 1000. Okay, this is the formula used. Okay, in the value, find out the value of n. The n equal to 1000 into v upon pi d. Okay, pi d. Find the value of the in the spindle speed. Okay, 207 uh, rpm. Okay, and their need for the rpm available for the list of, okay, 176 rpm, as the 280 is very high compare to the 207. For the calculate the machining time of the process, number of passes of the machining time, one the total length of the job is the one 120 plus the value is find the this is the length of the workpiece, and one is length here, and second length is here consider for the, okay, to not, this is not the value of the 180 plus 2 upon total of the feed rate into the n is the number of passes by the 170 in our n. Okay, given for the value of n. Fine. The machining time for one process is that na 2.898 minutes. Okay. The other is the find out the value of finishing given for the speed we were over 60 meter per minute, and the find the value of, and find the value of speed n is the also given for the value of v is the 30 minute meter per minute, and pi, and d is the value depth of the d is the given for in the okay, so 1000 into 30 upon pi into 42, the given for the value for the n. Okay, and the also for the find the value of in rpm available for the 440 rpm. Okay, the machining time for one passes, and one passes the given for the value of v, and n is the value for the 440. Okay, 440, and the so far this is the number of passes of the machines, and this is the value for the one 120 plus 2 upon 0.1. Okay, and into the n is the given for the 400. Okay, and this is the value of one passes the 0.2.77 minutes, and total machining time. The total machining time of the two into two machining time is the 2.888 plus 2.88 plus plus 2 point before find out value of the 2.77. Total find out the total machining time on these operations complete for the job 8.56 meters, okay, minute complete this job. And the facing, what is the facing, suppose that one is the facing is the also for the manufacturing operation consist for uh, the work performed to the face of the workpiece. Choose for the spindle speed is also need to the in RPM and attach it to fact the cutting tools. It the engage with the workpiece. Okay, with the workpiece is the gradually changes for the radius. Okay, and the other is the use in this operation. As the result, the actual cutting speed change. The actual cutting speed with the change for the highest value or required for the surface to almost the zero at the centers. Okay, the centers of the machines and cut for the job is used for the tools of the lathe machines. And important of some of other point in discuss in this lectures, okay. And suppose that I will to important turning, the taper turning. What is the taper turning? The machine the times calculate to the taper turning, and that depend upon the methods of using to the methods of find out the value of the very important. In the case of the taper turning attachment, the calculate is the similar to the machining as the speed of feed of motions is given by the carriage the pilot to the axis of rotation of the jobs and find the value of. However, the carriage is also parallel to the axis of rotation of the workpiece, and the tools is also fixed for opposite direction, okay, and the perform to the work. And second is the turning operation, the find the value of. This is formula also discussed for before slides, okay. And we were our pi dn upon 1000. This is the standard formula used in find the value of the turning. This is the turning operation, and v is the cutting speed and meter per minute, and the d is the diameter of the workpiece, and n is the rotational speed of the workpiece. Okay, all the parameters is the very constant in the use for the. This is calculate for the time machining times, and the one job complete for the kitna minute, and the one day find the value of one day in the whole operations in this in the operation. Whole value of the operations is the, okay, complete for the one day in the total jobs, okay. And for this is the also some of the standards considerations and mentions of the operations performed to the jobs, and other is the in the manufacturing industries, okay. And some and other knowledge is provided to this lectures is the very important lecture, and the sum of formulas used in the find out the value of the number of revolution, and the v is the speed of the workpiece, and find out and diameter of the workpiece. Some of formulae is discussed in this video. Thank you so much.